In the waning days of 2024, as humanity celebrated another year's survival, an automated telescope in the Chilean desert detected something extraordinary: a building-sized boulder hurtling through the cosmic dark with our planet directly in its crosshairs. What began as routine astronomical data would become the most terrifying celestial drama in recorded history, transforming asteroid 2024 YR4 into the second most dangerous object ever tracked by human civilization. On December 27, 2024, the Asteroid Terrestrial Impact Last Alert System telescope in Rio Hurtado, Chile, captured 4 faint points of light moving against the starfield. These weren't stars. They were images of a cosmic visitor that had already made its closest approach to Earth just 2 days earlier, on Christmas Day, passing at 828,800 kilometers. In a cruel twist of cosmic timing, this celestial object had slipped past unnoticed while families gathered to celebrate the holidays. The Atlas telescope system, spanning 4 locations globally with its revolutionary 7.4-degree field of view, represents humanity's most advanced early warning network. Each telescope can scan the entire visible sky in just 1,000 pointings, providing precious weeks of warning for objects like 2024 YR4. Yet even this remarkable system had missed the asteroid's approach, discovering it only after it had already begun retreating into space. This near miss highlighted a fundamental truth about our cosmic vulnerability. Even our best detection systems have blind spots, and the universe doesn't always give us advance warning. James Webb Space Telescope emergency observations in March 2025 revealed 2024 YR4's true dimensions: 60 meters in diameter, the height of a 15-story office building, equivalent to the Statue of Liberty from base to torch. This cosmic projectile weighed an estimated 280 million kilograms, spinning once every 19.5 minutes in a bizarre retrograde rotation that defied the usual patterns of our solar system. The asteroid's composition told a story millions of years in the making. Spectroscopic analysis revealed an S-type stony asteroid, likely migrated from the main asteroid belt through the gravitational chaos of planetary interactions. Its surface, dominated by fist-sized rocks rather than fine dust, reflected just 13% of the sunlight that struck it, a dark wanderer that had remained invisible until its moment of discovery. Most chilling was its classification: Torino Scale Level 3, the dreaded yellow zone, reserved for objects meriting immediate astronomical attention. Only 3 objects in the 25-year history of asteroid monitoring had ever achieved this designation. The infamous Apophis had reached Level 4 in 2004, while a handful of others briefly touched Level 2. Now 2024 YR4 stood as the second most dangerous asteroid in human experience. The Torino scale, ranging from 0 to 10, serves as humanity's cosmic threat level system, and anything above Level 2 triggers international alarm bells. Within weeks of discovery, orbital calculations revealed a nightmare scenario: 2.2% chance of Earth impact on December 22, 2032, odds roughly equivalent to rolling snake eyes with dice. But as additional observations poured in from telescopes worldwide, the probability climbed higher. On February 18, 2025, it peaked at 3.1%, the highest impact probability ever recorded for an asteroid of this size. To put this in perspective, insurance companies consider a 1% annual risk of house fire high enough to require coverage. Here, humanity faced triple those odds of cosmic catastrophe.
The potential energy release was staggering: 7.7 megatons of TNT equivalent, approximately 500 times more powerful than the Hiroshima atomic bomb. Impact velocity calculations showed the asteroid would strike Earth's atmosphere at 17.2 kilometers per second, over 38,000 miles per hour, creating a fireball visible from space. Computer simulations painted a terrifying picture. The asteroid would punch through Earth's atmosphere like a cosmic bullet, compressing air so violently it would reach temperatures hotter than the surface of the Sun. The risk corridor painted a path of potential devastation across the globe, from the eastern Pacific through northern South America, across the Atlantic to Africa, and extending through the Arabian Sea to densely populated regions of South Asia. Over 110 million people lived within the potential impact zone, including major cities like Bogota, Lagos, Mumbai, and Chennai. The uncertainty ellipse stretched across 3 continents, making evacuation planning virtually impossible. Where do you evacuate 110 million people when you don't know exactly where the hammer will fall? The announcement triggered the first ever activation of both UN-endorsed international asteroid response groups. The International Asteroid Warning Network, chaired by NASA, coordinated global observations, while the European Space Agency-led Space Mission Planning Advisory Group convened emergency meetings in Vienna to evaluate deflection options. Over 50 observatories worldwide contributed more than 350 observations in a desperate race against time. The European Southern Observatory's Very Large Telescope, the Subaru Telescope, and dozens of other facilities turned their most sensitive instruments toward this cosmic threat. Never before had the international astronomical community mobilized with such urgency and coordination. Social media exploded with trajectory simulations and public concern. At 2.3% impact probability, 2024 YR4 represented uncomfortably high odds for a potential city-killer asteroid. Amateur astronomers shared calculations, while the general public suddenly became intensely interested in planetary defense, asking questions humanity had never before needed to confront so urgently. Schools began teaching asteroid impact drills alongside earthquake preparedness. Historical comparisons revealed 2024 YR4's terrifying potential. On June 30, 1908, an almost identical asteroid, 50 to 60 meters in diameter, exploded over the Podkameneya Tunguska River in Siberia. The Tunguska event released 15 megatons of energy, 1,000 times more powerful than Hiroshima, flattening 80 million trees across 2,150 square kilometers, an area larger than New York City. The Tunguska object created no crater because it completely disintegrated in the atmosphere, vaporizing at an altitude of 5 to 10 kilometers in a phenomenon called an airburst. Remarkably, only 2 to 3 people may have died, purely due to the remote Siberian location. Had the explosion occurred over a major city, casualties could have numbered in the millions.
More recently, the 2013 Chelyabinsk meteor provided a modern demonstration of asteroid danger. At just 20 meters diameter, 1/3 the size of 2024 YR4, it exploded with 30 times the force of Hiroshima, injuring over 1,500 people and damaging 7,200 buildings across 6 cities. The shockwave shattered windows across 200 square miles, and the economic impact reached $33 million. If a 20-meter rock could cause such devastation, what would a 60-meter monster like 2024 YR4 unleash? Facing this unprecedented threat, the 2024 YR4 crisis became the ultimate test of human planetary defense capabilities. NASA's successful DART mission in 2022 had proven that kinetic impactor technology could alter an asteroid's trajectory. DART struck the 160-meter moonlet Dimorphos, changing its orbital period by 32 minutes. Far exceeding the 73-second minimum required for success. The momentum transfer proved more effective than predicted, with impact ejecta enhancing deflection by a factor of 25. Alternative concepts include the gravity tractor, a spacecraft that uses gravitational coupling to slowly alter an asteroid's trajectory over decades. Nuclear deflection remains the only viable option for large asteroids or short warning scenarios, though international treaties complicate development. In an unprecedented decision, the James Webb Space Telescope received emergency director's discretionary time, approximately 4 hours of the world's most valuable observing time split between March and May 2025. This marked the first time JWST had been pressed into planetary defense service. The decision wasn't made lightly. Every hour of JWST time is precious, with thousands of astronomers competing for observation slots. But when Earth itself might be at stake, scientific priorities shift dramatically. The results were revolutionary. JWST's combined near-infrared and mid-infrared observations refined 2024 YR4's size estimate from the ground-based range of 40 to 90 meters to a precise 53 to 67 meters. More critically, the Space Telescope improved orbital trajectory precision by 20%, providing the data needed to systematically eliminate Earth impact scenarios. The infrared observations also revealed the asteroid's thermal properties, rotation state, and surface composition with unprecedented detail. The asteroid's fate was sealed by this technological tour de force. February 18, 2025, peak probability of 3.1%. February 19, dropped to 1.5% after very large telescope observations. February 20 plummeted to 0.28%. February 23 reduced to 0.004%, essentially zero. The cosmic dice had been read, and humanity had dodged annihilation. Each new observation tightened the orbital calculations, shrinking the uncertainty ellipse until Earth lay safely outside the danger zone. As Earth impact risks evaporated, a different scenario emerged. Refined calculations revealed a 4.3% chance of lunar impact on December 22, 2023, around 1519 UTC. This wasn't catastrophe averted, it was scientific opportunity unprecedented. The potential lunar collision would occur at 13.9 kilometers per second, excavating a crater 500 to 2,000 meters in diameter with the energy of 5.2 megatons of TNT. The impact would create a flash potentially visible even in daylight across Earth's night side. For planetary scientists, this represents the holy grail of impact studies, the first observed natural lunar impact of a known asteroid with a precisely predicted trajectory. The event would excavate pristine lunar material not seen for billions of years, create detectable moonquakes, and provide unprecedented data on crater formation dynamics. Telescopes worldwide are already planning coordinated observation campaigns for this once-in-a-lifetime event.
The 2024 YR4 scenario exposed critical gaps in humanity's cosmic surveillance network. Despite revolutionary improvements since the 1992 SpaceGuard program began, only 40% of regionally dangerous asteroids are currently cataloged. Most impacts still arrive with hours or minutes of warning, if detected at all. The southern hemisphere remains particularly vulnerable, with limited telescope coverage. Objects approaching from the sun's direction create a massive blind spot that could hide asteroids until the final hours before impact. Current asteroid discovery rates of 1,500 to 2,000 objects annually represent remarkable progress, but expert estimates suggest we're finding only 10% of city-killer asteroids each year. 2024 YR4 will fade from observable range until June 2028, when it returns for another close approach at 8.0 million kilometers from Earth. This encounter will provide the extended observation arc needed to definitively determine the December 22, 2032 scenario. 4 additional years of orbital data to calculate whether humanity will witness the greatest impact spectacle in recorded history. The 2028 observations will enable radar studies impossible during the brief 2024-2025 window, potentially revealing the asteroid's internal structure and surface features.
Whether 2024 YR4 ultimately strikes the moon or misses entirely, its discovery has fundamentally changed humanity's relationship with cosmic threats. The asteroid demonstrated both our remaining vulnerabilities, discovered only after closest approach, and our growing planetary defense capabilities through unprecedented international scientific cooperation. The successful tracking and analysis represents a triumph of 21st century astronomy, showing that when faced with cosmic threats, humanity can respond with remarkable scientific precision and international unity. 2024 YR4 provided the ultimate preparation for a real asteroid emergency. The activation of UN-endorsed response protocols, mobilization of global observatory networks, and public engagement demonstrated that our species has evolved from powerless victims of cosmic chance to active defenders of our planetary home. The scenario tested every link in the planetary defense chain, from detection to tracking, from risk assessment to public communication, and found them functional, if not yet perfect. City-killer asteroids, like 2024, strike Earth roughly every 500 to 1,000 years, frequent enough that one has likely already begun its long journey toward Earth. With only 40% of such objects cataloged, statistically speaking, several undiscovered threats are already inbound, silently approaching through the darkness. The question isn't when another asteroid will threaten Earth, but when we'll spot it, and whether we'll have enough time to respond. In December 2032, humanity will discover whether the cosmos grants us a spectacular lunar fireworks display or simply another near miss in the ongoing cosmic lottery. Regardless of the outcome, 2024 YR4 has already secured its place in history as the asteroid that tested our planetary defenses and found them adequate to the task of protecting Earth. For the first time in Earth's 4.5 billion-year history, one species has developed the technology to watch the heavens and, when necessary, to change the cosmic dice roll in our favor. Asteroid 2024 YR4 proved that humanity has graduated from helpless observers to active participants in our planet's defense, a graduation that may ultimately determine whether civilization survives the inevitable next cosmic collision.